Hello students, I hope you are all doing well. So in this class, we are going to see about helium neon laser. You all know there are different types of laser, solid, liquid, gas and semiconductor laser. This helium neon comes under gas type of laser. So in this, the mixture of helium and neon gases are used and this is the active medium here. So we know that for any type of laser, active medium or laser medium is essential. For this helium neon laser, active medium is mixture of helium and neon gases. So this type of lasers is mainly used in laboratories due to its less heat. During its operations, it emit less heat, so its life period is long. So helium neon laser was invented in the year 1961 by Ely, Javan, Bennett, and Heriot. So from this helium neon laser, we will get a continuous wave laser, and lies in the wavelength range of 6,328 angstrom, and it is in the red in color, and it lies in the visible range. Next, helium neon laser construction. So it consists of three parts. One is a pumping source. Next one is gain medium or active medium, and third one is resonant cavity. Pumping method is the pumping method. There are different type of pumping methods. In this, we are using the electrical discharge method. There is we are pumping the atom from the ground state to the excited state by means of external voltage. Next one is active medium. Here the laser action takes place, and from this we will get the laser source. Third one is resonant cavity. That's the glass medium plus two pair of reflecting mirrors is known as resonant cavity. First one is pumping source. So this pumping source is used to achieve the population inversion condition. So what is population inversion? That is the number of atoms in the excited state is greater than the number of atoms in the ground state. This is the main condition to achieve the laser action. The pumping method involved here is electrical discharge method pumping. So here the external DC source is used to pump the atom from the ground level to the excited level. So when the DC power is applied to the glass tube, so which is built up with two electrodes, one is cathode, another one is anode. And we are applying the power supply. What happens? The electrons are accelerated from the electrodes. These electrons collide with the helium and neon mixtures and it pumps the helium atom to the excited state, and the helium atom again transfers some of the energy to the neon atom, and the laser action will takes place. Next, active medium or gain medium. Here the helium and neon is taken in the ratio of 10:1. That the 10:1 not only it does not denote the for a 10 part of helium, 1 part of neon. It denotes the pressure of the helium and neon. That is, helium is taken in 1 millibar pressure and neon is taken in the pressure of 0.1 millibar. Next one is a resonant cavity. That is a glass tube plus two reflecting mirrors is called as resonant cavity. The glass tube is in the glass tube we are taking the mixture of helium and neon gas, and two mirrors are placed behind this glass tube. One is 100% reflecting, another one is partially reflecting. So here that is semi-silver means that is partially reflecting means through that mirror we are getting the continuous wave laser. Next one is function of helium neon laser. Here, when the in the glass tube, the mixture of helium and neon is built. That is active medium. When you are applying the external source, that is DC power source, is applied to this helium and neon mixture. That is the we are applying initially we are applying the DC source to the glass tube, which is filled with helium and neon. So in this, there are two electrodes are there. One is cathode and the other is anode. When we are applying the power supply, what happened? The electrons are accelerated from the with high speed, and this electron initially collide with the ground state helium atom, and it makes the atom, that helium atom, from the ground level to the excited level, that is from the E1 to E3, E4 and E5. So from this excited helium, again collide transfer its energy to the neon atom, which is in the ground state. The neon atom take this energy from the helium and it goes to the excited state E5. In the excited state, it can't sustain over long time. From this, it emits spontaneously to the E4 level, E3 level, and E2 level, and again it transfers to the ground level E1. When the neon transfer from the E5 to E4, the bandgap dB is very small, and it emits the laser in the wavelength of 3391 angstrom. From when neon jumps from the level E5 to E2, here the band gap between E5 and E2 is very large, and the laser is up in the range of 6328 angstrom. When the atom, neon atom, from the E3 level to the E1 level, it is obtained the wavelength is obtained in the range of 1152 angstrom. So this is our E5, E3, and E2 is the radioactive transition. From this, we are getting the laser source in the wavelength of this range from 1100 to 6300 range. So when the jump from E2 to E1, it is a non-radioactive transition. So this equation, that is from this energy level diagram, we can say that the laser source, which is obtained from this helium neon, lies in the range of 6328 angstrom and is in the visible range. From this, we obtain the red color source. This equation, helium plus electron, gives helium by Astrock plus E1, and next equation, helium plus neon, gives neon plus helium. That is, initially the electron collide with the helium atom, and it make the atom from the helium atom from the ground state to the excited state, plus E1. That E and E1. E1 denotes that this electron gives some of the energy to the helium and it transfer from the ground level to excited level. So in order to show the difference between these two, here it is taken as E and here it is taken as E1. This excited helium again collides with the ground state neon atom, and it makes the atom from this neon atom from the ground level to the excited level plus helium. So the helium transfers some of the energy to the neon, and the neon goes to the upper level. So here the asterisk symbol denotes the variation in the energies. As we have seen in the energy level diagram, that is the transition from E5 to E4, the way we will obtain the wavelength in the range of 3391 angstrom, or 3.391 microns. From E5 to E2, we will get in the range of 6332.8 nanometer. We have to denote the units properly. From the helium neon laser, we will get a continuous laser source in the range of 6328 angstrom. If the neon jumps from the E3 to Two level means the laser is up in the range of 1152 angstrom and it lies in the infrared region. When once we obtain the light in the range of 3300, now it's the visible range we can able to see this light source. For any type of laser, we have to go through what are the advantages and disadvantages and applications involved here. For the advantages, we know as we have seen, it is mainly used in the laboratories and it emits very less amount of heat. Its duration of life duration is longer, and then it is lies in the wavelength source. It is in the visible range, and it is low cost and it is high stability. Next one is disadvantages. It is low efficiency. The gain is low, and it's having power also very less. Next one is applications. It mainly used in the college laboratories and school laboratories. Next one is it is used in the scientific instruments and it also used in industries. That's all. Let's go for a brief recap. So in this class, what you have seen, what is helium neon laser, what is gas laser, and what is helium neon laser, and what are the main components involved in this laser. Next one is construction. Next one is working of laser, what the energy level diagram, what are the advantages, disadvantages, and application of this helium neon laser. I hope you are understand this well. Thank you. How do you put me?